We have another interesting question to solve, and this will be your question number 9 for the day. There are two charges. So let's take this charge, two charges. One, let me call it O, the other one is A. This charge is 3 into 10 to the power minus 8 coulomb. This charge is minus 2 into 10 to the power minus 8 coulomb. If I combine, they are separated by distance of 15 centimeter, or let it 15 into 10 to the power minus 2 meter. This is the charge we are speaking about, the setup we are speaking about. Now, there is a line, as you can see, that joins these two charges. At what point in this line, let's say there is some point in this line where at some point in this line the potential is going to be 0. What is that point? Where is that point? Now let's say that this point is at x from the left. So on the right side it becomes 15 minus x. Let's become about centimeters. 15 minus x centimeter. Now why am I assuming that the charge is on this side? Why not on this side? It cannot be, because we are saying that the potential is adding up to 0. So that means the electric potential coming from O and then that is coming from A add up and they become 0. But if we keep moving towards the left, that will not add up to 0. So this is the setup we have. So there is a positive charge, there is a negative charge. So at some point, so the negative charge is coming like this, this intensity, right? The positive charge intensity is coming like that. I mean, it's not to scale, but somewhere both get cancelled. Okay, they get cancelled. So that should be somewhere in the middle. But if we go left, right, we are going to get not that cancellation. We are going to have some charge, some potential that is coming from A on this side. So we have to look for this point somewhere within this range. That is why we have assumed that the x, the point, the one that we are looking at is x centimeter from the left. So we are saying V1 plus V2, that is V1 is coming from this and V2 is coming from this. So that is equal to 0 at P. Let's say this is P. This is the point P. That means, so V is nothing but 1 by 4 pi epsilon naught into Q by R. So let's do this. 1 by 4 pi epsilon naught into Q1 by R plus Q2 by R2 equals 0. So 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Q1 is a positive charge, 3 into 10 to the power minus 8, and then the distance is x. Q2 is a negative charge, 2 into 10 to the power minus 8. See, 2 into 10 to the power minus 8, and the distance is 15 minus x. Take this. So instead of 15, I'll take this centimeter, 0.15 minus x. Now this should be equal to 0. Now if you do this, what we are getting is 9 by this, it got 0. So we are looking at 3 by x, 0. Okay, so 3 by x plus 2 by 0.15 minus x. This is equal to 0. If you solve for it, you get x is equal to 9 centimeter. But what if P is on the other side? Let's look at this. the charge would be like this, and then okay, so at some point this becomes 0. Okay, now why is it not like that on the left side? Because if you look at the charge values itself, this is lesser than the positive charge. So on the left side you are going to feel this positive charge. However, on the right side at some point this minus 2 into 10 to the power minus 8 could be neutralized by what is coming from A, what is coming from the positive charge. So we will consider X, consider P also. There is a possibility it is on the right side. So if you look at it, then from here it is at a distance of 15 plus X. Now let's look at this to be at a distance of X from A. Then this we know it's already 15 centimeter. So what we are going to do is we are going to do the calculation again. 9 into 10 to the power 9. We have 3 into 10 to the power minus 8. And that is at a distance of, so here we have 3 into 10 to the power minus 8. And here we have at A we have 2 into 10 to the power minus 8. So 3 into 10 to the power minus 8 is at a distance of 0.15 plus X. Then plus 2 into 10 to the power minus 8. This is at a distance of X. That equals 0. Now if you solve for this, you get a value of X which is equal to 0.45 meter, or it's equals 45 centimeter.